Ooh, being recorded now.
Hi, welcome to this session where we're going to talk about what security exploits can be addressed with ISGs, which are the isolation and sanitization standards. This is a great intersection, something that I care about because I do come from a sort of exploitation background. So very quickly, just welcome what we expect you to participate. We're going to do a lot of information sharing and collaboration. Everything we do is open, everything is recorded, everything we create here is released under open source and as Creative Commons or open source license. We expect everybody to respect each other, everybody should be professional, and any issues just raise it to us. And here are the hashtag to use and the Slack to collaborate. And fundamentally, you're here to learn. So let's stop the sharing and let's open up the conversation. So this is one of those where I actually don't have a lot of good stuff, a lot of stuff prepared, because what we want, it's probably actually worth just probably sharing my screen. Actually, let me just open up the ISG page and the repo that we've got. So we can kind of view it as a base, and then we'll take it from there. Okay, so, and again, let's be interactive. Let's collaborate. Let's all sort of, brainstorm on the best way to make this happen. So you should be able to see my screen now. Cool. So there's the session. So actually, one of the things that would be good if everybody could help here is that we should improve this page. So this is the landing page. So it'd be good to improve it, and you can edit on the site. If you go to the Open Security Summit website, you can edit it. But it'd be good to start to add some information and some info on this. And also, there's the repo that we have. Actually, that's a good point. It should be linked from here. So, okay, we need to link the repo from here, which is the repo. I'll put on the chat now, but it's the one where, on, here we go, on the Summit sites, which we can use to collaborate. So, here we go. And these are the ISGs, right? So this is currently, the current ISGs have been published. And the title of today's session is the typical kind of exploits that can occur that we should be able to prevent through the ISGs. So who can actually keep track of the topics? Can somebody keep a list? Actually, let me do something. Let me just pause this. All right, let's start with this, right? So what are good? What's the list of vulnerabilities that the ISGs will prevent? From you guys' point of view.
Hello, can you hear me?
Yep.
Oh, it's Vin.
Yep, I can hear you.
I suppose this is a continuation of the discussions we've been having in the last 2 or 3 sessions.
Yep.
And so taking PNG as our example that we've been using, it's rather like the exploits that have been taking place in, for example, in the PNG signature, and far more malicious ones like those. And I suppose the ISGs, to summarize, if we show we prevent them, we are adhering to the A standard, and we are preventing these kind of exploits taking place, especially so with our core engine, which does a lot more than probably what the ISG does.
Yes, I think our engine is a superset really of what a lot of what the ISGs do, but that doesn't mean there aren't little loopholes in there somewhere where the ISG might be pointing out something that perhaps we need to look at, obviously.
Yeah,
but that's already a very interesting question, right? Because when you look at like the stuff that we do, right? The way I look at this is that there should be a reason for everything that we, that is done to a file, right? So if you look at, let's look at the CDR space, right? So, we are just one implementer, right, of that. But if you look at the CDR space, the question is, why would you do something, right? Like, if you're doing something to a file, where is that coming from?
Well, I mean, sorry.
I suppose another interesting perspective is we do over the years we've learned to do lots of good things, but we haven't been able to easily explain to customers why we do certain things and what benefits they're getting. And I guess with the ISG coming in and use of that as a guidance, at least it shows that there is a reason why we're doing it now more easily.
You're sort of quantifying it, but I mean, the whole concept of Glassdoor, which put it above everybody else as far as I was concerned, was that we just treat the known good. Anything else, we don't look for known bad, we just look for known good. And that is what gets passed through into the substitute document. And by a big side effect of that is that all the bad stuff is filtered out automatically. We don't have to look for it. We just make sure we conform to the spec. And just look at the known good, pass that through, and there's your document. That's my feeling anyway.
But actually, that's an interesting point, right? Because when we, I say, we say that we do the known good. Okay, you guys should be able to see the screen now. So please, start. You should know the link is there to edit. So please jump in, right, and start editing this, right, and. Because if you look at like the known goods, comments, right? You only know sometimes what's good, right? If you know what's bad, right? So, the bottom line, right? If I go into, let's say, the PNG, some of the validation, some of the requirements that exist here, right? Actually, I think I've cleaned up the image one, the EXIF, right? So if you look at some of these requirements, right, a number of these, right, are the places, right, where...
Well, you see, let me take number one there. Validate the required set of tags are present in the IFD. Well, we will code to that anyway as being the known good. If the spec says that this set of tags is required, that's what we look for. That's it. That's the known good.
Yeah, we had a meeting this morning. We were going through looking at the PNG camera or the PNG ISGs, and it is very much taken very much from the specs, the same as us. That this is what's meant to be there. These are the rules say you should have 3 of these, 2 of those, never more than 1 of those, and those are exactly the requirements and specs that we've conformed to, and built sort of hundreds or even thousands of rules along that basis. So we could certainly correlate all of the ones that are highlighted in the ISGs, and that is one of the conclusions we came to, that one approach would be to simply go through all of those and actually tag any of our existing rules to highlight those particular tests to show that, yep, we do that, and we can build a file with that particular vulnerability or that particular error in, run the thing through and prove that it gets remediated and removed, and simply validate that our validation is already dealing with these things. And if it isn't, clearly then it's the next one to add. But in most cases, I think a lot will be found there. But it's a case of, we can go through and say, right, we can put a tag against that to say, this is an ISG number XYZ, this matches to our rule, whatever ID number we have against that, and prove that with some suitably generated files that it actually matches and does precisely as it says there. I think that the question you raise is, what do you actually sort of, what exploits do you prevent? I think the trouble is, we have always taken this different philosophy of, we will go through the specification and we will find every possible rule or caveat in there that says this must be this way, this must correlate to that, that must match that, this mustn't be there, and followed that, and then proven against, you know, massive amounts of known virus files being able to be passed through our camera and our cameras and come at the other end as clean, safe files. So, and while it's quite right to sort of say yes, well, let's cross-check against these things and say, yeah, here's a set of vulnerabilities, prove that we don't, you know, those vulnerabilities are dealt with. Likewise, we also go through and say, right, here's a bunch of 5,000 virus files of that particular file type, pass it through our system and rerun against those tools that validate it and say, yep, those vulnerabilities or those viruses have been removed. But Glasswall's philosophy has always been, you know, get to that spec and find every little nook and cranny and corner, such that the tool never knows and never actually goes specifically looking for a known problem. It's always looking for only the bits that are correct. Therefore, that's what gives it its 0-day capability, is that it's effectively always putting a barrier up to anything that shouldn't be there. So you've always got that advantage of being able to say, if anything comes through that isn't meant to be here, that we've never thought about before, there's a pretty good chance that it's going to say, I don't want that, and bang, out it goes. It's not accepted. So it's just a slightly different thing. So we simply just gone and said, we will cover every little tiny point in the specifications and check that the sorts of things that are being, exactly the sorts of things that are being described in these the ISGs, we've identified them from the structure, from the rules, from the specifications, and from, in some cases, some reverse engineering of file data, that where we get bits and pieces of edge cases that weren't originally in the specs. We suddenly go, actually, there's some real world ones out here that do something slightly different. Well, what's the proper approach to that? Right, we can add in some additional rules and some additional tests to make sure that we validate to that acceptable way of working, and effectively augment these. And that's perhaps where there is a lot of stuff that we could potentially isolate and extend some of these sorts of these ISGs particularly. I mean, there was something I noticed in the word spec the other day. I was going, yep, you check that, we do that. Oh, hang on, you don't look for that particular thing, and we look for that. So there are probably lots of things simply by reviewing and working through these, going, yep, we'll prove that we're up to the spec of this. If there's something we find in here that we didn't know about, good,
okay, but let's look at,
and then,
okay,
you know, if we find something new, we can push it back into the community.
Yeah. So, but let's take, okay, that the case you're talking about, right, is basically the logic here is that measure environment to look for known goods and focus, you know, one focus, right? Okay, but by the way, you have to remember that this is not just about Glasswall, right? So one remit, right, is to look for known goods.
Yeah, I mean, there's quite a few other companies out there who
do the same thing, right?
trying to do the same sort of thing. Yes.
Yeah. So, and then what we also have is that you got not good, but also this is, you know, a matching to the spec, right?
Yes.
You know, matching to file spec, right?
Yes.
But now the question to ask is, what is the security advantage of this? Like, what are, for example, the exploits that we're doing, and what we actually are really protecting against, right?
Yeah, I mean, the sort of things you've pointed there, you know, obviously,
right?
Vulnerabilities in terms of places being able to store, you know, virus data, you know, sort of your payloads. So clearly, you know, clearly.
Don't go there yet. Don't go there
yeah.
Yet,
okay. Well, I mean, it's one of the things that we do end up doing.
Yes, but that's one that we go against the spec. Because here's the interesting thing.
Well, it is part of the spec as well. If something says here there should be 10 items in this list, and someone sneaks a 15th on the end that contains something, then clearly we will go, all right, there should only be 10. There's an identified 10. We'll throw away the one at the end. Therefore, inherently, we'll dispose of a place that could have been hiding something.
Yes, but there's a lot of things that we, for example, do. For example, remove metadata, remove macros, remove things which are valid content.
Yes. Oh, yes, I see what you mean. Yeah.
They by design supposed to be there.
Yes.
Right. So one remit here. So let's first look at the non-data leakage element of this, because I think there's two parts. In fact, let's look at the non-data leakage, and
yeah, see, because that's the other side of the picture, isn't it? It's not,
yeah.
so you've got the incoming side, but the outgoing side, you could say, oh, yeah, well, in fact, it's two sides to it. Your outgoing side, you might want to remove metadata because you don't want useful information sneaking out from under the bonnet. So that's the outgoing side of it.
Yeah. So basically, what you got is malformed files, right? Malformed files. Because you always have to ask the why, right? The so what, right? Why does it matter, right? Why, if you have a file that doesn't match the spec, what's the problem, right? You got vulnerabilities, you got crashes, right? Crashes caused by. So I'm trying to map here is actually.
Which of course could have been malformed by a Trojan program running in your company. So you think you've produced a perfectly valid file with your safe data, and a client receives it from you thinking you're a safe place to receive it from. Or might even be an update of the file that they sent you in the first place, and wondering why it's now suddenly got something.
But if you look outside, the known functionality that we know is bad, right? Let's just map out what else do we do, right? So for what else does this technology do? Sorry, when you rebuild a file, according to the ISG standard, right? And I think this is interesting because I would argue that the ISG should contain all the malicious behaviors or malicious side effects of a file. Would you guys agree with that?
That would appear to be the sorts of things that they're trying to describe, the things where things can be done wrong for a malicious purpose. Yes.
Yeah.
So they are narrowing it down in that approach, more a case of, whereas we just simply go, right, we'll try and cover everything and not worry about what the purpose of it is. This is obviously narrowing down to say, right, here's a type of error that can be used for a malicious purpose.
Well, we're relying on the side effect of just keeping what we think's good.
Yeah, and I think in most cases that's precisely what would happen. Yeah.
Yeah.
But that, like I said, that line, right? Like known good, right? Like a macros could be a good thing, right? Macros from a file spec point of view, JavaScript from a PDF point of view is known good, right?
Well, that's why we allow them to remove them as well, because we know that they can be used for malicious purposes, but they can also be a real aid with the spreadsheet. Macros are, can be a godsend.
Yeah.
So, in fact, some of our clients want us to keep macros in because they rely on them. So that's why we give them a choice. So we know it's a known good, but we also know it's a potential payload.
Yeah. And I actually think that this goes into a spectrum, right? So
well, that area, of course, is one of those ones where yes, you start needing to get into something that can deal with looking to whitelist that information or look at it in more depth. And that's always been the thing. As you expand these things out, you find more and more cases where actually that's something you could have a sub process that potentially is done better by another tool, which I think some of our partners have done work with, and clearly you can't try and take on everything within one framework. It makes more sense to break up and differentiate and say, right, well, this area we can strip out if you don't want it. If you do want to accept it, but you then want to do some other testing on it, then, and that is part of the reason we do the export and disassemblies, because there are other clients who have got options to say, well, we actually want to dig deeper into that because we know a different type of reuse or exploit or vulnerability or thing that is a very narrow case, but we'd like to be able to use that and take care of that ourselves and then reintegrate it into your file. So like any of these things, you can keep finding more and more ways of.
So look, here's the actions that the ISG recommends, which I actually think is quite a nice way to put it, right? So you've got, in a way, you got 1, 2, 3, you got 6 actions, right? That you can do. You can validate, you can replace, you can remove, You can have external filter requirements, you can review it, or you can reject the whole thing.
Yep.
Well, replace is basically sanitize, isn't it? Or remediate. Replace is what you do with remediation, isn't it? Remove is when we sanitize it away. Validate we do, of course. What's review?
Yeah, we do very much. Yes, I mean, reject, clearly you've got something you can't like, reject the entire file.
Yeah, disallow.
Validating is what we do. We check that things actually conform, if they conform, it goes through. Replace would be part of a remedy.
Remedy, yeah.
Say that's not what should be there, but we can tidy it to what it should be. Sanitization is removing for us.
Yeah.
It's remove sanitization for it. And external filtering, as I was saying, we can expose through export the internals of something and say, right, if you want to filter that layer and return it to us. Review, I'm not quite.
Yeah, what's that? Present the data structure.
Yes. Okay. Well, I suppose that happens in cases where there is something that we can't do much with or not sure of. Then a file does get parked somewhere for.
Is review almost like an analysis report?
Well,
no, review is what I think
suggesting it's been parked in a file. The file's actually been pulled out to one side for
quarantined.
Oh, I see.
What I'm looking for.
It's been quarantined, ready for somebody to look at, to say.
Yeah, but I think they're very explicit here, right? So if you look at this example, right, it's not about take a look at the document, it's take a look at this thing. So let's say here, you got, record fields and number of data types, blah, blah, blah. You got MP3 contains a multiple programs that contain this, can be extract using this. So basically you want to present the list of programs in the streams, and then you have a human review it. But that should be just that bit there. Right?
Can I ask a question? I was thinking about the rules for how we divide up which thing would go to which which process. So like removing it or replacing it. The different. I was thinking about the rules. How I guess currently, how do you have those rules being determined? How do you have them like separated into those different areas? You understand what I mean?
I think so. I mean within our software, how we deal with these different things. Well, we have initially, as the files are actually loaded in, we have a suite of schemas that dictate how to extract the valid information, the valid structures from the file. So if the file is really, really badly corrupted or just simply not the right file, then that whole thing's going to get rejected because we won't find valid, neat items. So often, quite a lot of the validation rules that some validation rules I see in the ISGs where it says, oh, you must have this header field or something else. They would be literally go, well, that header file's not there, bang, that's not the file. End of story. It wouldn't be read any further. If it gets past that stage, you're saying, yes, these all look like the right structures, they've got the right little headings and so on. Then we go to the next validation stage where we have a whole suite of rules that are along the lines of this type of field must have a value in this subfield in it that's between range X and Y. So a lot of the tests in the ISGs are very much the same as that. And some of those will be a cross-reference saying this field such and such must be between X and Y only if its parent field elsewhere tells you it's of this particular type. So you might find that particular record type appears in multiple times, but you have to look back up to its parent or a parent further up to say, is it in the right mode to have the value bigger than this or lower than this or have this subcomponent within it. So we have that level of validation. And then we have a third level where we do a series of callbacks as we go down through the tree of data that we've constructed for a file to pick up things that are involved in, you need to look here earlier in the file to remember to work out that these subsequent children should have these values or shouldn't be here, or there should be 10 of them when the field at the start says there should be 10. So there's lots of those sorts of correlations that we can do. And then as we reach those, each of those rules, whether it's
Do you have?
Hello, sorry.
Sorry, I was going to just ask. Do you have a repo that those are all on the current process?
We currently have the sample code, the sample software, yes, but the rule sets we don't have those published. No, I mean, yes.
Which we need
Okay,
to.
I was just wondering.
Let me show an example of kind of maybe visualize. So if you take this spreadsheet here, right? Can you see this guy? Can you guys see my screen?
Yep.
So this is a spreadsheet.
You see it?
It's an Excel document, right? What we do for the analysis is, we build an internal representation of this. This is basically what everybody does, right? You basically take the files and you create an internal representation of the file. And in our case, with the latest version of the engine, we can actually publish it, the export. So we can actually export what the internal representation of the file looks like, including, for example, the images, right? So these are the images actually extracted from here that you can download as a zip. So this is the kind of stuff that when you go to the forensic workbench, you can actually download this from there. And then what you do here is, this is, for example, actually, it's actually a different file, but this is actually, yeah, so this is the XLS file. So this is the XML representation of what that content looks like. So you can see that you can then, this is in XML, you can see everything gets kind of mapped into this. So you can now start to apply rules to this, because you got everything in this kind of object.
So in which way, how do you have the actual code for the rules?
No, that's currently encoded into our camera code. We may start publishing some of those as extensions to the ISGs, perhaps.
Mm-hmm. But that's what I want exactly. Right?
I mean,
I want to see a rule that checks for this. Basically, we need to have a unit test, right? That is literally a rule to check that. And then, each tool can implement, I think there's some open source tools that would be good to expand, but each tool can then look at it, how to actually implement this internally. But one of the things we need to create is a set of test cases that allow us to actually confirm, and know where to find, and know exactly what should be the actions to be done here. So you have the success criteria for each of these.
Okay, I guess the reason I'm asking and what I'm looking at here is, you've probably heard of Yara. It's helps like divide, Virus Total.
Yeah.
They have an open source
we used to
tool.
test against that.
Okay, so you've heard of Yara, then you have the open source tool there that kind of helps to identify the different areas. I was thinking, rather than reinventing that whole area, building off of it so that instead of just checking whether or not it was a virus, actually having it set up so that you're running using this type of system, and you can readjust it to however you want, but rather than having to reinvent it, using this type of system to actually search for things, and then having your system set up to be able to actually replace or alter it in accordance with the ISGs so that the file is usable, versus how like Virus Total, it doesn't actually give you a file that's usable. It just tells you whether or not there's something in the file. But that way you have an easier way of being able to search it, I guess, being able to identify and classify the samples. Does that make sense at all?
Yeah, it does.
I think the main difference being with VirusTotal and the approach that we use is they use signatures to detect whether a file is a threat or not. So that would be different to what we are doing. So we don't rely on signatures.
That's the main point of Glasswall, as Ajit says. We
Yeah.
don't rely on signatures. We're not interested
So
in virus signatures, that is.
yes, yes. So I think even I'm not fully sure about Yara, but I think even Yara would use signature matching. So we are not reliant on signature
It
matching.
does, yeah.
So that is the main difference between us and the others.
With some of the testing we've done,
and the consequence of us processing the files would remove the bad signatures of the files that would have the bad signatures. So that is a consequence of the way that we process files.
yeah, I think that's something we've used in the past for proofs, isn't it? That
Yes,
a particular signature disappears because it was in the payload. Therefore, we've proven that's gone. Sometimes, though, the signature is the way it's constructed, and it's a valid construct that they've latched onto, but the payload's been removed,
But
and
this is actually really cool,
some
right?
of these tools then don't actually highlight that we've done our job, which is a slight problem in doing that testing.
Well, we have the advantage of 0-day sanitization, don't we?
Mm.
We don't care about a new signature coming online and a new virus. We just throw it out because it's not the known good, and that's gone. We don't have to care about it.
Yeah, but look at this graph, right? This is a pretty cool graph, right? So this is a graph from WannaCry, right? And actually, what he also has is that on the payload, he's actually also looking at the files that were embedded, right, or were used as part of it, right? So, and also has the links that maybe were triggered from the file, right? So if you start to analyze even before and after, or start to understand what is the threat profile of a file has, then that gives you a good understanding, right? Also of how dangerous it is. That's the kind of stuff probably they were talking about.
Yeah, I see.
But let's go back to the concept here, right? So what are we? So when you validate against the ISG, right? What are you protecting against? Yeah, that was a good one.
We are protecting against whatever vulnerabilities that are already identified, not against anything else.
Vulnerabilities where?
Whatever that has been identified. So a set of CVEs that has already been identified. That is all we are protecting against. So if you are using ISG, whatever vulnerabilities that is out there in the open, that is what we are protecting against.
Yeah, so by CVEs, right? You basically is the CVEs, for example, right? Sorry.
Yeah. So all the non CVEs at the time of writing of those are the ISGs. Those are the ones that we are protecting against.
Yeah, but that's the kind of 0-day. That's because, but even if it's a 5-day, it doesn't matter, right? Somebody could be using an out-of-date file parser, right? The place where that vulnerability gets exploited is because of the file parsers, right?
Yes, yes.
So if the file parsers were perfect, the security impact of a file that complies with ISG or not would be lower. Would be not problematic. Correct?
Yes, yes.
I mean, looking at the some of these ISGs, I mean, there are certainly some areas there where there are similar sorts of validation tests that are nice and generic enough that would actually capture and dispose of the sorts of things that we do. So they are similar in places. There seems to be a bias towards places in particular problems that people have seen. But some of the validations and some of the reactions are very much nice and general and would capture anything in that range. So it's kind of a mixture. But
we have to be pragmatic, right? So when you look at it, right, these are real things, right? So if you look at, for example, these FAR exploits and and some other, kind of file types, right? There's been some real world exploits done with this thing, right? And masquerading file types, which basically, could bypass file uploads, right? File detection, right? So this is what you're doing here is you bypassing file detection, right?
Yeah,
Be that
one of the first things we look for. Yeah.
Yeah. But so what does the ISG protects against, right? So the first level is protects against vulnerabilities in file parsers, crashes by malformed files, masquerading file types, and I guess the other big one is dangerous functionality, which I want to go next, right? Dangerous functionality, and then data extraction, right? Leak, right?
Mm-hmm.
Is there anything else that protect against the ISG will give you?
Data leaks is in terms of removing metadata and things like that.
Yeah.
Yeah.
So the logic here, and I think this is a very important thing, right? So if you look at definitions, right? So ISG should cover all files that has security effects, right? And can we say, right, here that if an exploit is done, with using a method not covered by the ISG, that's a gap, right?
Oh, definitely.
Right, by the ISG, right? That is a vuln in the ISG, right? Or a gap, whatever you want to call it, right?
Yes.
So, because the ISG, right, should cover all those scenarios, right?
Yeah, most of them. Yeah.
Right?
Yeah.
So, because I think the reality is that you can have a non-compliant file as per spec, right?
Yeah. Should we say ISGs won't protect against 0-day?
Yeah. So, so this is unknown, right? Unknown, right?
Yeah.
That's your 0-day, right? So unknown vulnerabilities are your 0 days.
Yeah.
Right? So here's the thing, right? So if you have a non-spec compliant file, right, but what's it called, ISG compliant, right? So this file should be safe, right?
What if the ISG's out of date?
Well, then that's a problem with the ISG, right? So that's a bug, assuming the ISG is correct. So that's a vulnerability in the ISG, right?
Yeah, that would be a limitation. Yeah.
So this is, okay, what about the definition, right?
Yeah.
A non-spec compliant, a file, right?
Yeah.
That is non-spec compliant, but ISG compliant, should be safe, right? A file.
By safe, what do you mean, Dennis?
That's a very good point. So
yeah, I'm not sure about your definition there, because I mean the ISGs look to be doing the same sorts of applying the same sorts of logic as us. In actually, I mean, reading through some of them, they very much are sort of following the same sort of thing. What sort of spec elements are that can be potentially right or wrong. So
yeah,
we say it's non-spec ISG.
I think their approach is the other way around, reverse engineering sort of approach. I guess I don't think I'm sure, but they look at CVEs and they use that as their guidance to come up with their guidance. I guess I'm not fully sure whether that's the approach that they take.
Well, to be fair, one thing that I wish there were more, but I couldn't find, is actually CVEs mapped to particular issues, right? So, for example, I would love to see a CVE connected to this guy here, and one connected to this guy here. And in fact, that's what I was trying to think about. That once, as we expand the thinking, for example, of so as we expand the thinking, let's say here, right, of mapping the requirements, right? One of the things that'll be good to hear is actually have CVE entries. Right? And so that would be a good thing to do, where you could have, right, if you think about it, you could have CVEs here, right? CVE entries. Or you could have, at the top, right? You could also have them here. Right? So you could have a CVE that is connected to the file type generically. In fact, you can even have it here, right? So it depends on the level of granularity that even information is available on that CVE. You can have one per recommendation type, one specifically on the data on the item, or one at document level or file type level. But we'll go to this, right? So a file, let's go by bits. Okay, so safe is no exploits and no data leak, and then I would say, see this bit, right? See this, see that bit. Oh, come on. Right? So if you look at, this bit here, right? It's basically, you got that bit, right? So no exploits and no data leak. That's what we call by safe, right? So it's a file that is okay, so actually you have three options, right? A file that is spec compliant and ISG compliant should be safe, right? I think we can agree with that one, right?
Yep.
Right? A file that is non-spec compliant, but ISG compliant should also be safe.
Yes, it could be a malformed file.
Yeah. So okay, carry on. I'm just trying to.
Denise,
Yeah.
I'm
Some
struggling
terminology here.
with that non-spec compliant because
I'm not sure about that.
Because doesn't that mean, although if the file might meet the ISG compliant, if we were to follow that rule, does that mean we could potentially let something through?
Well,
I'm guessing what you're saying is because we do get files that are not quite spec compliant, but that the reader programs aren't strict enough and happily read it, which is obviously how vulnerabilities get in, isn't it? Whereas we're trying to be very pedantic and say we'll absolutely make this spec compliant, and then potentially offer throw out files that a reader would say, well, that file's fine, but we're saying no, we don't like it. But you're sort of suggesting that ISGs are picking up on the very specific things that are known to be wrong.
Well, but I believe that's what they do,
vulnerabilities.
right? I don't think the ISGs are, even they say in the beginning, right? They're not determined, they're not describing the spec in detail.
No, they're just picking on the things that are unknown vulnerabilities.
Well, yes. So unknown vulnerabilities,
or potential vulnerabilities, yeah.
So the ISG, my understanding is the ISG, even by design, is only looking at the areas of the spec that have security implications.
Yeah, I'm with you. Yes.
So the ISG is not looking at parts of the spec that if some file, for example, is malformat, is going to create a problem, with image displays or other things, etc. It doesn't care about that, right? What it cares about is that the blocks and the stuff and the bits that have security implications are covered.
Yeah, I see where you're coming from. So it's the subset of the sort of things we do, aimed at the elements that are known to be places where you can use, to break file systems. So things that have already been seen in the past, and say, well, the vulnerability in there is the fact that you could do this. So if we check for that vulnerability and clean it out, therefore any attempt at using that vector from any other source is going to be thwarted. We're working on a basis of going across the entire spec for every little aspect of it. That should inherently cover the same things. Clearly,
yeah, but here's now the next one, right? You could have a file that is compliant to the spec,
yep,
but doesn't comply to the non-ISG, right? To the ISG, and it will be unsafe, right?
yes. So that would then, that's, yeah, so which is the hole that we need to plug. That's clearly, then we've gone to spec. We think we've covered it all. The ISGs have pointed out a vulnerability in what we believe to be a compliant way, a spec compliant construct within the file, but there is a vulnerability in there that somehow that then misses. And clearly that is something then we need to add in as an additional.
Yeah, but sometimes you look, do you guys remember this one? Who's old enough to remember this one? Right? So this was an insane vulnerability, right? In Windows, right? And the problem with this, it was that, if I remember correctly, I'm pretty sure this is the one, that this was, you know, and there's that thing. Okay, Steve Gibson actually, you know, trying to say it was a backdoor. So this was a good example, right? This was not a bug. This was caused by a feature.
Was this the one where, as you viewed over files, information got displayed? Or was that a different?
No,
one?
This was caused. There you go. It was the handling of Windows metadata files, because you could have a set abort procedure. This is an insane vulnerability, right? This is basically, you could basically create a problem in a file, and you could actually provide shellcode to execute in the file.
Well, the trouble is, metafiles, that were they the capture of the GDI instruction sets? So it was literally the drawing instructions just being packaged up.
No, it was, I think, to do with the way to provide a way for printers to recover. So it's almost,
okay.
I think it was a way to say, if the printer cannot parse this thing, here's a bit of shellcode that you can execute to do a soft landing or something like that.
Oh, okay, helpful.
but my point with this, right, is this is a good example of the spec, right, was wrong, right? Literally, the spec was wrong. And when I look at some of the stuff that the spec says, what the spec is basically doing is looking at functionality of features that were added to the file formats that might make sense in another planet, right, or another time scale, or in certain situations, but in other situations are dangerous. If I look, even
well, I just remind me of something else. We'll come back to in a sec.
Like even the simple example as macros, right, and others, you know, and embedded files and all that jazz. Those are good examples of functionality that the spec says X, but you almost it's almost like I view the ISG as a security spec for a file.
It's almost sort of saying it is perfectly valid to leave the front door open. So if somebody walks in, well, we actually said it's, you know, it's safe, therefore you know, it is silly, isn't it? The thing it just bound to remind me, it was when we were looking initially at the OXML, the Office open format, had a nice defined set of XSDs to say this is exactly how the XML should be formed. We built our cameras around that, and then we started finding all these optional plugins where there were sort of these free format XMLs in, and you think, well, what do we validate them against? And they actually ship the XSDs as part of the file. So it's like, how can you can validate it against, but you're actually giving the validation data with the file. So it's like, here's the key and the lock at the same time. You know?
Yeah, and that's what I'm saying, that I think the interesting case here, right, in this scenario, is to say that if there is an exploit or data leakage, right, that can occur from a file, and the brief is prevent exploits and data leaks, right? And that's the brief, right? Then anything that can do that should be an ISG. Because you actually, the other thing that's more interesting here, so go on. No, sorry. What do you guys think of that?
No, I wasn't saying anything else. It was.
Because the reality is, right, and if you think about it, and this is actually something quite interesting, right, is that what we want, right, in a way, is to create, right? ISG compliant files, right? That's fundamentally the objective, right? If you think about it, because they are the save files. And because the other problem here, right, is that we can't say that the objective is to create spec compliant files, right? Because we know that a chunk of tools already able to process, right, non-compliant files.
I suppose where you're going with this is a more relaxed view of how strict we've been, like with what we've done on the cloud, where we've reversed some of the thinking and introduced the bypass feature. So rather than being so strict all the time and potentially stop files going through, if we follow the ISG, it's some way of allowing files that we wouldn't have allowed through before, but at least we can fall back to the ISG and say this is a security format standard that we're following.
That's actually a really good point.
What you're saying is that what we let through is not likely to have a payload, that because the ISG doesn't think it does.
Well, or we have data support. Yeah.
Yeah, but then does that then risk the downside of that if the ISGs have not covered a particular thing because these are based on vulnerabilities that have been discovered? So it kind of goes back on the other side again, doesn't it? That by being compliant to spec, we're dealing with stuff that may not have been dealt with before. I get the point that there is the potential possibility that if there is effectively it's catch-22, isn't it? That you've got an effective vulnerability in a compliant file. But then how do you know that?
But that's bound to happen, right? Like, but what you have, right? Like, look, basically macros, right, are vulnerabilities of compliant files.
I know where you're going. Yeah.
Right? JavaScript, metadata leakage, right? Extra information, encoding of data without the user knowing, privacy, data being injected in there that, the user doesn't want from a privacy point of view. Those are vulnerabilities that belong to compliant files. Right?
Yeah, I think this is where always the problem that we've had the conditional switching to allow us to decide what to put those in or not. But as soon as you then switch those off or on in whatever particular way you're doing it, you're then pushing the requirements down onto the client to decide, do I want this or not? And of course, how are they meant to decide that?
Yeah, but that look, the other thing here to understand is that it's a lot of it is the objective is it's also about risk management, right? Right. So what we want to allow, almost like fact-based risk decisions, right? So if you look at it, if of course, right, that if you look at now the scale of risk, right? We can actually, in fact, we can even frame it like this, right? So if you look at risk, risk of a file, you can basically say that the highest risk, if I take this, right, is highest, like top. This is basically maybe top to bottom. I could say that the highest risk file is the one that has the top to bottom. Top to bottom. You could say that this is the most risky file, right? Then you got that, and then you have that. Does that make sense? So you can actually say high, right?
Yeah, so least
Medium.
safest at the bottom. Yeah.
Yeah, medium, right?
And he seems to have started the
Low.
audience meeting.
Yeah, I think we need to jump in a minute. Yeah, but can you guys see, right? In this case, right? That's where this is the risk, right? Risk of vulnerabilities of risk mapping, right? Risk of file, right? It's the highest when it's non-compliant, then medium, then low. So if you had to let the file go through, if you let a file go through that is, ISG compliant, actually, sorry, this is, yeah. So the file that you want to let through is actually this, actually missing one. So this should be, right, the flow, right?
I suppose actually, we I don't know how complicated it would make it, but I guess you could also factor in, the policy switching as well. So seeing, how risky a file is if you allow through scripts, if you allow, scripts
Yeah.
would be the main thing, So all right, that makes the table a bit more complicated, but you could do that, which would assist in people. Well, it's just asking to be able to specify how dangerous
I think
a
that's
file
where
is.
I think that's where we want to go with some of the machine learning, so we can start to actually say that you
Yeah.
get to the bottom here, but you can also then look at, well, how risky are file types of that particular file, and you can score it that way. So you can add another dimension in there.
Yeah,
And
that's actually what I was doing. So I was taking the analysis and running it through the machine learning algorithm, and it could give you even like a percentage of what the file, if the file could be malignant. So that could be an extra layer on top of that.
Yes, I mean, it is. We'd done some experiments with that some years back, but now that you've got the export data where you can actually see the structure of it rather than just the summaries, then you'd actually probably be able to do analysis on that a little bit more effectively. So I think I've been meaning to get back to you about that, how you extract that info.
And I think this is where we need to draw it, because I think we all need to jump into another meeting.
Yes.
Yeah.
I think it's what everybody here. So I'm gonna end the recording. But I think it was really good, actually. This thread is.
They're just saying on the other meeting they're going to wait a minute, so we better jump in.
Yeah. All right. Cool. Well, I think definitely should continue.
Okay, that's been great.
At 5 o'clock. All right, guys. There you go. See you.
Okay, bye.
Cheers. Bye.